Okay, today we're going to start looking at adding and subtracting polynomials. And last video we talked about what it means to be terms, and we said that terms can be or are separated by a plus or minus sign and cannot be combined. So today we're going to look at what it means to be able to combine those terms. And the easy answer is anytime they have the same power of x or the exponent on the variable, those terms are able to be combined. So like anytime you're just adding two numbers together, 5 and 4, those two things combine to give you 9 because they are like terms. Now looking at something with a variable, if we have x to the first power and x to the first power, we have 1 and 3 of them here. So we're going to collect how many of those x's we have, and we end up with 4x. And then the next example is x squareds. So we have 7x squareds here, and we're taking away 4x squareds. So 7 minus 4 would give us 3x squareds. Now the important thing to remember here is anytime we are combining like terms with addition or subtraction, we are never going to change the exponent. And then the last thing I have listed over here is standard form. And standard form of a polynomial starts with the highest power of x and then moves down. So in general, we would write that as ax squared plus bx plus c, where we're starting with the x squared and then moving down to the bx and then moving down to the constant term that does not have a variable with it. So let's take a look at a couple of these examples. So the first example here, you see we have an x squared here, we have 7 of them, and then we have 9x squareds there. So since they both are x to the second power, those two things are able to combine. So all we simply have to do is take the 7x squareds here and add the 9 more to them that we have there. So our answer here is 16x squared. Again, notice all I'm doing is collecting how many of those x squareds I have. The x squared does not change. The second one, we have 3x, and then we're subtracting away 5x. So since they are both x terms, we can go ahead and combine those. So we do 3 minus 5, we end up with a negative 2x. So it's okay to have a negative coefficient with our x's. We're just doing the subtraction and taking away how many they asked us to there. The third one, we have a group of a bunch of terms here. So to make sure that my answer is in standard form, the easiest thing to do is to go ahead and start with the highest power of x. So if we do that, if we look here, we've got 2x squareds, and then we have a 5x and a 7x. So the x squared is the highest power of x. So I'm going to start with that term, and notice it does not have another x squared to combine with, so that's fine. All we have to do is start with that term and write it down. Now I like to underline, or we can cross it out, just to make sure that when we have a longer problem that I don't forget any of my terms. So now moving down the line, after x squared, I look for any x terms, and of course that's all we have left. So we have 5x's here and 7x's there, which would combine to give us a positive 12x. And now that I have all my terms underlined, that is my final answer, and notice it is in standard form. Highest power of x, and then moving down with whatever we have. Okay, now finally we have about as complicated as a problem as we can get for just adding and subtracting. It's just a big group of terms here that we just have to see which one of these are like terms and combine. So what we're going to do to ensure that we're in standard form is we're going to start with the highest power of x, which is this 4x cubed right here, because the 3 as the exponent is the highest exponent of the thing, and we do not have anyone to combine with, so we're going to just write it down. Now moving down, we check to see if there's any x to the second power terms, and notice we have a negative 3x squared and negative 17x squared. So those two guys can combine because they're both x squareds, giving us a negative 20 x squared. Negative 3 minus 17 more gives us negative 20. And then we look for x to the first power. There's not any x to the first power, so we can move down to just a constant. And then we have 5 plus 8 gives us a positive 13. Again, we are in standard form because we have the highest power of x, and then we move down with whatever we have. It is totally fine that we do not have an x to the first power here. We are still in standard form as long as we are starting